Okay. Alrighty. So, we'll get this going.
I don't know that I'd put that in just yet.
No.
We've still got to mark it, set the camera up.
Oh, okay.
All that.
They're using exosome.
Yeah.
Okay.
As stress strain data, which is what he wanted, and ideally what most people want. So the stress data is not a big deal. You know your cross-sectional area. Hopefully you've measured it before you destroy your sample. You know your cross-sectional area, you divide the force by that, and now you know your stress. The strain, on the other hand, this displacement number is only telling you what this is moving. Okay. And as you're pulling down, you're compressing these guys. You're pulling on this load cell. Anywhere that the machine can stretch, it will. And so what we measure on this as far as how much is moved is not how much your sample has stretched. It's that much plus whatever the machine has stretched.
Okay.
So it's not true strain data, it's just how much the bottom head has moved.
And same deal with this one. I don't
All of
know.
them, yeah. And so if you need true strain data, like if your calculations depend on that strain being correct, then you've got to set up an extensometer.
Okay.
If you don't care and you just want to know the shapes and you're comparing this one to that one, then you can forget the extensometer. It makes it a lot easier, but you won't have accurate strain data.
Okay.
That makes
So,
sense.
Do you guys know at this point?
I think it would be nice to get as accurate as we can.
Okay. So we'll use the camera. Okay, so now what?
Now, it's camera
What's left on the slides?
time. Oh, left one. Group controls, we just talked about that.
We talked about eSwitch.
The manual handset. I don't like the manual handset. I don't think we should use it.
Well, I want you to train them on it anyway.
Oh, okay. Fine. Alright. This is the manual handset. This is how you break things.
Okay.
That's how Marcus breaks things.
Okay. This is a good way to. It's jogging it, but not with the mouse and the buttons right there. So we're gonna push. You have to push this handset button first, which gives control to this guy, and then you can push this button to activate the wheel.
Yeah. Did it blink off? There you go.
Oh, there you go. Okay. This thing is very sensitive. If you'll watch, I'm gonna just move it very slightly, and you can see it moving.
And the directions are the same. Down is down. Up
Pulling
is up.
down, you're pulling it down. Pushing up. You have to be careful though, because when you actually have a sample in there, very small displacements are going to give you very high forces. So I use this wheel. We're calibrating a load cell,
Yeah.
and I moved it a smidge, and all of a sudden we had 10,000 pounds of force on it.
Oh.
Dang.
So
Okay.
So the wheel is speed sensitive. So if you move it fast, it will go a long ways. If
Yeah.
you go really slow, it will move really slow as well. So it,
And then you
it
wanna
works
turn
pretty
that
well.
off.
It can be handy, but it's
Okay.
just an alternate way to move it. If you prefer doing it with a computer, go for it.
I would recommend that.
I like using the handset. And mostly, here's when I use the handset.
Yeah.
If I need to be over here looking to see where something is and I want to move it, I can just leave it clamped in down here and I can just watch it and I can get it right in where I want it.
Okay.
Yeah. So, which is a little harder to do. You can do it over there, but.
You have to go back and forth.
Okay. Sorry,
Yeah,
keep going.
no, you're good.
Now, everybody that Marcus trains is not going to want to use the handset.
Nope. You always want the rabbit. You want that to be red. E-stop, use in emergencies. Okay, grips. We talked about these. Storing the cabinet. You don't want to sit them down in the greasy faces.
Yeah, we saw all this.
Yeah.
Or you showed us all this.
Don't stab your fingers with the hook when you're moving the springs. People have done that.
Dang.
That's
I've
why.
done that.
Yeah.
You
I
haven't
stabbed
done
myself with a hand today.
Oh,
Not
Only
with
a
one
matter
of
of
these.
time.
But okay. You don't want to close grips on themselves without a sample. They're tool steel, right?
Yeah, so super hard brittle.
Super
steel.
hard, very brittle. They'll
Okay.
just crunch and.
do you know what kind of tool steel? Is it D2
I have no
or?
idea.
Yeah.
All I know is it's hard. We've broken
Right.
it before.
Remember, when you're swapping out the ones on the top, the only thing holding them in there are those two springs.
Okay.
So when you take those out, it'll just fall and
Fall.
smush your hands.
Okay.
So you want to or feet or everything else. So be careful with those. Just really, I just press up with one hand while I get the second one off, and then you can, yeah. Okay. You want as big a contact area as you can between the grips and your specimen. Obviously, we're not in an ideal situation with that, but when you can, I mean, that's why it's gonna be nice to switch to the smaller ones because you're gonna have more contact relative to the size of it.
If you get to choose the dimensions of your sample, which you guys do, make them so they're going at least halfway through the grip
Yeah.
Okay.
or more.
So you make these a little longer.
Well, in this case, I think they are halfway.
Yeah. Yeah. Mm-hmm.
Yeah, if you were using this one for a lot more, then
I'll just double check just to make sure that it would fit halfway.
Also,
Yeah.
you should talk to whoever's running the project. It would be interesting to have to do different orientations
Just at the
and
print.
yeah.
see what it does.
It could be.
Yeah,
I don't know.
I'm
how
curious.
much longer. Just
Okay.
good.
You don't need to put it all the way to the bottom, but at least halfway. Minimize gripping on hardened materials.
So we've had
Yeah.
like you know how they hardened the dog bones for 250.
Yep.
That's super hard after they harden them and
Yeah.
the grips are like fully worn out now.
Yeah,
All
it just
flat.
wrecks the grips.
Yeah.
Yeah.
So in you guys' case, your material's not super hard. You'll be fine.
Okay.
We could probably skip practice until we're ready to go.
Yeah.
Unless you guys want to run through a fake sample.
I think we're good until we're ready to go.
Yeah.
Okay, so we need to go look at what tests we uploaded. Okay. So up here, you see it says that there's no open test. And this is where you know a lot more than I do.
Great. Let's do it. Okay. So, this tells you which controller you're connected to, which user you're logged in as, and which test you have open. We don't have one open, so we're going to open one. You haven't created one in the past yet, so I'm going to open a template and get you started with one. So if I click on the little down arrow, I can create a new test from an existing test. So I'm going to go to one I already know. I'm going to go to the PSC folder, and there's these reference tests that you can copy. This is kind of for us to use. If you guys want to grab one, feel free, but after we're done creating it, you'll have it. You shouldn't need to come in here.
Okay.
But I'm just going to use this template. It's the one we usually use for this kind of test. I'm going to open it, and at this point, resave it. Otherwise, they'll be saving their stuff in our folder over top of our templates, right?
okay.
Because we just opened it.
We just opened it, yeah. So you need to save that.
Yep, so just do file, save as. We're going to save it as a test, not a template. And for you guys, since you're logged in under the PSC, I'm going to just put your stuff in this long-term projects. This is where we store stuff that's longer than a semester.
Okay.
And I'm going to make you guys since you're probably only going to have one test, I'm not going to bother putting it in its own folder.
Okay.
But let's name it something.
Would one test be like
So
for like multiple or just like one?
you'll use this one test for all of your samples,
Okay.
and you'll see why in a minute. Whose lab did you say you're Dr.
Sterling Baird.
So I'm gonna put Baird.
So basically what we're doing is when you create this test, you're gonna tell it you're giving it the instructions. It's like after we put a sample in, we want the machine to pull at this rate, right?
Yeah. So as long as you're not doing completely different kinds of tests that have a completely different test procedure,
Okay.
then they'll all be under here.
The same.
Yep. So I'm just gonna name it Baird Tensile Test. Does that sound good?
Yeah.
Should be able to find that easy. Okay, and then you can see that it's now.
Okay.
We've got that test loaded. Okay, so we're gonna jump down here to the test definition. The procedure. This is what it's gonna do during your test, and it's kind of like a flow diagram. This is what was already. Otherwise, this would be blank if you started from scratch.
Mm-hmm.
So this is what loading it from another test does for you. Is it's already done. You just need to change a few parameters. So the first thing it's going to do is just going to pop up a window telling you to press the run arrow when you're ready to go. That's just for convenience for you guys. The second thing it's going to do is zero your displacement. So just see how we're not at zero anymore.
Yeah.
When you're putting your sample in and you're getting it just right, you may move it around with the jog buttons or the hand thing, and you won't be right at zero anymore. That doesn't matter. You still have about 3 inches up and about 3 inches down, but this will just zero it for you so that your data starts from zero. So
Nice.
that's just a convenience thing as well. Doesn't really change anything. Just know that it's going to do that. Then this little block is going to record your data. This block is going to tell it to move and how far and how fast. This block is going to say if you ever go over 100,000 pounds, shut things down because something's wrong. So it's those interlock limits. This one's going to watch for your sample to break, and it will stop the test for you. Also, just a convenience. It will basically, if you get to a peak and you drop 90% from that peak, it will consider your sample broken.
Okay.
And we can use that for your convenience. If you want to decide when it's broken and stop it yourself, we can also just disable this.
Okay.
And then this is just a button that we added. It will pop up right here when we're running a test, and that's your user button. If you want to stop the test early, you can hit that button. So you'll notice that these are all in a parallel path configuration. So it's going to run all of these at the same time.
Mm-hmm.
So any one of them can shut off. the
Yeah.
test.
This one can't, but
Yeah.
the rest of them can.
Mhm.
So it will be moving. This block will tell it to move. This will tell it to collect data. It'll be looking for force. It'll be looking for brake. It'll be looking for you to press the button. And if any of those happen, it will jump out of that loop and end the test. The last thing we do at the end of the test is save your data to your file.
Okay.
So let's go do that real quick. So I'm going to change the location for the folder path. It's here in these project folders. Currently you're in the PSC folder, so I'm going to put it in the PSC folder under data, long term, and this one will have a whole bunch of files in it, so we're going to create your own folder here. And I'm just going to call Baird.
Okay.
Okay, so all of your data will be saved to that Baird folder. It's going to create a new folder for each sample.
CSV.
Yeah, do you want them to be CSV or tab delimited? And if you don't know what that means, I can explain.
I
We know
think
what
CSV
is.
should be good. What
So
what's the
a
benefit
tab
of each?
delimited, Excel files are tab delimited
Okay.
by nature.
Okay.
Excel can open CSV files, but they're not its native format.
Probably CSV, because then if
Okay.
we want to export it somewhere else,
Great.
that might.
And then do you want your units to be in English or metric?
Metric.
Okay. And for your info, I don't know if I showed you this already.
Mhm.
These are two unit sets that I made because this SI and this English don't have degrees or percent. Or there's a bunch of things missing in there.
Okay.
So I made these two at the bottom. So just always use one of these two.
Yeah.
Okay, and then it's going to be, these are the channels it's going to record: time, displacement, and force. That's all we have to record. Actually, that's not true. We need to add the extensometer on there. So to do that, you just click on the plus sign, and it's not there.
It's not
It's,
set up.
This is something for you to know,
Okay.
but not to train people on necessarily. If we go to this resources tab, if there's ever something missing that should be there,
Yeah.
or that's there and causing problems, this is how you either get rid of it or add it.
I remember this.
Right.
Yeah.
So resources, we can import all of the resources, or we can delete extra ones. So those
okay.
two ways will help you out. I'm going to import everything, all unused, and now it should be here. Still not there. That's interesting. We'll come back to that. I'm not sure why.
That was funny, Kevin. They came over to me and like, have you ever seen this before?
Okay, so now we're measuring to try to figure out exactly what the cross-sectional area is.
It was super fun though.
6.03, 6.04.
6.04.
Yeah.
We camped for a couple days in just the national forest.
6.04
So we
times.
just went like 5 minutes down a fire road. We were in the middle of the woods without a soul in sight. And you can't have fires in the national
You'll want to do.
You just have to be this certain distance from the road.
Yeah. This is awesome. So we're in this sweet.
Okay, there we
First
go.
in the Kaibab.
5.83.
I did some primitive camping in southern Utah. It's just, you're just allowed.
5 point.
Oh, it was so chill.
So we have a
couple
cross-sectional
hours
area
long
of
trip.
35.2132.
I will say I don't usually like.
Alright, so that should be everything as far as setting up the test.
Well, I'm gonna give this to you. I gotta go work on it.
And then this test run display will configure your user interface, what you want it to look like. So right now it's going to be just displaying force versus time and displacement versus time. We can do force versus displacement. We can do whatever you want. I don't know what you're interested in.
Just kinda flush
So
out.
we'd probably do force versus displacement.
Okay, and that's it.
Can we do both?
Yeah.
Oh yeah. Well, yeah. Let's do both.
Okay. Do you want to do both by meaning you want force versus displacement
And force versus time.
and force versus time, and you want displacement versus time as well?
Yeah.
Okay. I'm just going to make this one shorter and put them over here. Oops. Whatever. It's gonna just stay like that. Sorry.
Okay. No, that's
Sorry
all good.
about that.
That's okay.
Nope, it's gonna stay like that. Okay, so this one we're gonna set up as the y-axis is gonna be force. Sorry, the y signal is gonna be force. The x signal is gonna be displacement.
This is how you added the individual charts
Yep.
or graphs. I mean.
And we're gonna make your units be in newtons and the x-axis is going to be in millimeters. Okay, and it should have done it over here. So we've got force, newtons, millimeters. And this one is going to be force. We're gonna make it force versus time. Versus time. This one's gonna be displacement. And millimeters versus time. Okay. And I'm gonna make these. Yeah, close enough. Okay. Oh, and I don't know how slow we're gonna end up pulling these, but right now we've got 720 seconds of time to display on the chart. This one actually doesn't matter because it's not versus time, so I'm just gonna put like 720 seconds.
Okay.
This one I'm gonna also put something that's reasonable at least. And you're not gonna lose any data, it just won't show it on the screen. So, anything else you want in your user interface besides that?
I don't think so.
Okay, so we've got our procedure set, we've got our time test run display set. Let me show you what I was having problems with on this. stupid
Yeah,
thing.
because you were trying to add the XML
Yeah.
data.
So I was right here in the export data, and I was trying to add it here,
Oh, is it
and
in?
it didn't appear because
that-
it wasn't collecting it.
Isn't it collecting
Yep.
it?
So I didn't
Yeah.
realize which spot I was in, and I just needed to add it here,
Okay.
and then it was here to select.
Okay.
So
And that's that aerial. I'm sorry.
AOX.
AOX.
Axial.
Sorry.
Yep.
Yeah.
Okay, so that's set. Now we need to set up one other quick thing. It's already set to let them put in their sample rate
Okay.
and their ramp 2 distance and the ramp rate.
Okay.
This one is fixed and those are fine. These are fixed and those are fine. Now I just want to go make sure that the right variables show up for them to select.
Okay.
If I go to variables here and I know one of them is going to be test run name, and it should have a check mark there on pretest for it to pop up at the beginning of the test. So that
Okay.
one, and the ramp rate should have it, and the ramp 2 distance should have it.
Okay.
So all the things we want to configure at the beginning.
If there's anything that you don't want, you can just.
You uncheck it.
Yeah.
And now I'm just going to pretend like when I run a test, I'm going to cancel it. I just want to see the window pop up.
Okay.
So when
Oh, I
when
see.
you start a test, this window will pop up and it will let you choose these things.
Okay.
And
Sample rate, ramp rate.
we're going to set them up so like this one says use previous test run value. So whatever they put in them will appear next time. So they don't have to put it in every time.
Okay. That's
Um,
good.
Same thing there. Same thing there. This one you can't do that on.
Okay.
I mean, it says that, but it doesn't really do it.
Right.
But I'm going to put these in. Do you know if your ramp rates? I'm going to put them in millimeters per minute,
Okay.
and I'm going to put this one in millimeters, just so they're the same as your other thing. Now, just changing here won't make them stick. I have to go change the variables.
Okay.
How do you guys feel about this
Oh,
order?
minutes.
Like, would you rather have the test run name on top? Or are you fine with?
I think that's fine.
Yeah.
So, the only one of those I needed to change was this one. Needs to be in millimeters.
And the speed.
Needs to be in millimeters per second. Minute. Okay. So now when I start a test, those are in the right.
Okay.
Okay, so your test is written. Do you have any questions thus far?
I don't think so. Any of the variables we need to change over there.
You shouldn't even need to go into any
Okay,
of this.
cool,
This
never
was
mind.
mostly to show him what
Okay,
to do.
cool.
Yeah. Because now
Okay.
once your test is set up, you
Then we
never
just
have
come
to
in and do it
set
every
up.
time.
So I'm going to close this test and show you what it looks like when you start from scratch.
Okay.
Okay. So it'll come in just like it did when we started. You'll notice there's nothing here under test, and it says there's no open test. So you'll just go to open test. You'll go into these long-term projects, Baird pencil tests, and there's the test that we're ready to run.
Nice.
So, and then you would just hit, when you're ready, you'd hit new test run. It would ask you how fast you want to sample, how fast you want to pull, where you want to pull to, and what you want to name this sample.
Okay.
And then put something in. Okay, and then now your test is running, but hasn't started yet. And so this is that window we told it to pop up to tell you to press the green arrow to begin the test. So when you press that green arrow, your test will
gonna go.
then start.
Okay.
It will start moving.
Which right now it'll move a millimeter
Yeah.
over the course of 45 seconds, and it'll stop.
So it's collecting your data. If you wanted to stop, it would go until you hit that 1 millimeter that I told it, or you can hit this press to end test early, and it will just pop out of that loop and save your
Okay.
data.
Great.
So there's the test that we just ran. If you want to go look at it, you can click on this guy, go back to monitor, there's your data. Or it should be saved here in the projects folder. Data, monitor, there.
Ta-da.
Not to be confused with bear. So there's the one we did. The sample name that we put will be the first part of that folder name.
Okay.
Unfortunately, this software always uses the same name for all of the data. So all of them are named this. But they will be within a folder with the name you gave it.
Okay.
And if you open this,
Are these older computers?
um,
Random question.
they're not super old, maybe 3 to 5 years old.
Okay, so not really.
It's definitely more just a Windows problem than
Yeah.
age of the computer.
Yeah.
So you'll notice right here, it has that same sample name, whatever you put in it, here in the folder. So if you ever lose track of it, just open the file up, it'll be there in the header.
Okay.
Okay, that's great.
So, and then this is what your data will look like: seconds, millimeters, newtons, and percent string. So, any questions?
I don't think so.
Okay.
I think we just gotta do it.
Now, I don't know how much time you guys have. I've got time to keep going if you want to keep going.
Yeah.
Yeah, let's do it.
Okay, so at this point, I'm going to delete this guy. We don't need that data.
So Sterling said we wanted the strain, which we can do with the video, and then, but it'll be.
So, at least for now, we keep it right here. The camera's in the box, and the mounting system's here. We'll do the mounting system first. So, show them how to put that on if you know how. Grab it, and I'll show you how to do it. So it has these little triangular things, and they fit in these little triangular things. And these red things are how you lock and unlock them. So just hold those in and slide them on there. So just make sure they're good and tight. It shouldn't be able to, like, lift up on it, it shouldn't come out.
Yeah.
Okay, great.
Okay.
Great. So now your camera will mount on here.
Okay.
So you can see it from where you're standing, but it doesn't line up with the center line right now. So we've got to fix that. So those
Which
two,
is with.
the other one, but yeah.
Is it these guys on the back here?
The all four.
All four. Yeah.
And just make it the other side.
Yeah, it's just these T-slot. Ish.
And you're just loosening them, you don't want to pull them out. And
There
then
we
that
go.
whole rail will slide back and forth.
And we're able to rotate this a little bit, yeah.
Yeah. So just get close to the center line.
Maybe.
No, you're good. Keep going.
I'm gonna go get a Sharpie and number these and then get the cross sections for all of them right now.
I've got one if you want it.
Hey Ronnie, there's a we have a Sharpie over here.
Alright.
Thank you. This is the one you did?
I think I set it on the table. So
Okay, I'll just redo this.
yeah.
So camera looks for lines on your
Mhm.
part, so I'll put it on. So yeah, put it either down there or on the side where you want.
Okay, so I don't know if the camera got that, but basically when you write your sampling numbers and information on the sets, make sure they're on the parts that are going to be in the grips. Otherwise, it'll mess with like the camera.
Show 'em, and before you flip it over, show them this. So this connector goes right in here with the light, and it's got a little red dot there that you line up with the red dot on the connector, and it just pops in there. It doesn't twist; it just goes straight in.
Okay.
And
And
these,
these just slide.
yeah, these little bearings go in those little slides.
No, it's just slidey, so you don't want to just.
Don't
Yeah,
be careful.
It can't slide off the front. There's a block.
Do you want it to go all the way to the front, or?
It doesn't matter where you.
It doesn't matter the placement.
This
Okay.
thing. So this is a little thing to keep it from sliding off the back.
Okay.
It's just a pin that locks in the up position.
Okay.
But I still wouldn't depend on that. It's just for emergencies.
Mm-hmm.
There's a knob on this side that locks it in place.
Okay.
Then where's the knob? Okay,
Yeah.
right there.
Yep.
Okay.
So just put it in the middle. It doesn't matter.
Now we're gonna be bringing this down.
Yeah. So out of the way is good.
Out of the way is that.
Yes. Right. And before you put them in there, slide them through that. Probably from the front side. Doesn't matter a lot, but. Sorry, and I guess if you're gonna open it, you could have connected it, but.
It's all good. Yeah, just rest.
So the reason we use this is otherwise it would just be tugging on those cables
Okay.
right on the connector. So just make sure you have this thing taking up the slack so that those don't get pulled on.
Great.
Force the computer. Cord goes to this.
Power strip.
So in both
Okay.
desks we have this hanging out, just so that we don't have cables crossing here,
Yeah.
so people don't trip on them.
Alright. This guy.
So that is the signal from the camera. We need to give it to the data collection system of the machine, which is these wires go down to the black control box.
Okay.
So you need to find the one that says AOX on it. I don't know which one it is. That one. This one.
AOX is what we want.
Yep.
Plug it in.
Wait, is there a little?
Yeah, Marcus, as soon as you can, get the camera powered on because it takes like 2 minutes for it to initialize.
Power's
Yes.
on.
So
It doesn't have a light on.
to turn it on.
Oh, okay.
You have to flip this power switch here
Mm-hmm.
and this one here until it turns red.
Okay.
Sometimes it turns on, sometimes it doesn't.
Cool.
And then you flip this power switch.
Okay.
Okay,
And it's
so-
green.
Is that? And I remember that does take.
Yeah, it takes a minute. So now while you're explaining other things, it can be initializing.
Okay.
Reminder that we're using the angle, the 98. And then get the jaws to clamp.
Yeah.
And are we at zero roughly with this guy?
Yeah. Mm-hmm.
Does that look pretty square? It's not perfect, but it's not bad.
Yeah.
Okay.
Okay.
Alright, so now do you know what to do with the camera? So we'll do that before we bring this down.
No.
Switch here.
Mm.
We'll set it to a line first. Okay. So see how it's two lazy lines
Yes.
there.
Yeah.
So I turn and then.
If we loosen the camera so that it can move, you undo that. No. Okay, great. And then just move forward and back. See how those lines get closer together and further apart? That helps you set the distance of the camera.
Okay.
So you
So
want them to
get them
be-
to overlap on top of that sample there. There you go. So I'm going to move to the center-ish of that guy. Okay, and I can also, I just know this, but you would find that out in a minute. The camera's
Clamping.
too high.
It is. Okay.
So I'm going to lower it.
I see, because they.
Well, I just kind of know where the camera needs to go.
Yeah.
So we're just going to get roughly in the middle there.
Okay.
Now you'll just move it in and out until those line up over each other.
Alright.
They're pretty close. The sample's bent, so it's not going to be exact, but and then clamp it down there.
And then this is just like a practice one.
And this way, and then you're good.
Okay.
Sweet.
We're not there yet, but in a second we will be. Putting that switch in the middle puts nothing out. Putting it at the bottom turns the lights on for measuring, and then this changes the intensity of the light. So I'm going to put it all the way up for now.
Okay.
And those still look good. We'll come back to that so we don't get blinded.
So open up the, I don't know, the circle one, the Gucci looking logo.
Okay, and since it's been on for a while, it's already found the camera and everything's initialized. When it says searching, that means that it's searching for the lines on your sample, not that the software is searching for the camera. It's already found it. If it says anything else, like it's booting, looking for optics, I can't find it, whatever, you usually just have to wait longer.
Okay.
But make sure the camera's on or it won't ever find it if it's not on.
So for all our samples, do we need to have like horizontal lines on them? Okay.
And you may have noticed the sample we put in there has
Definitely.
lines.
Yeah.
Okay, so this, the interface that we're looking at right now is the simpler one. We're going to go to the more advanced one by clicking on that gear symbol. Okay, so now, blind myself.
I remember this.
Okay, so see that dip right there?
That's one of the
those
lines.
Is that the top line
Yeah.
or the bottom line?
Top line.
Top line, so we can't see the bottom line yet, so the camera's not down far enough.
Okay.
So I'm going to keep lowering the camera until you can see. So we have hit the bottom of our thing here.
Yes.
So we can either loosen these and drop it, or we can bring this up, which is much easier. So why don't we do that?
Yeah. So we're gonna go back in here, and look, we're good to go. We're gonna jog it up a little bit.
And that's just.
That's probably good. Let's see.
I see it on there yet.
Do you want to put go wavy in front of it? Maybe?
Keep.
Oh, here. Let's. Oh, does it? This is before the. Up. Okay.
So this one's still the top one?
Yes.
Okay, so yeah, keep coming up. There it is.
And do you want it just in the middle?
No. So
No. So there's these little bounds.
yeah, so,
Yeah, so I see it.
anything in the window it can see, anything outside the window it can't.
Mhm.
Okay.
So this is the bottom line. So once I've clamped onto this sample, which one of these two will stretch the sample?
Bottom.
The bottom one. So this line right here, will it go up or down while it's getting pulled? It'll go down.
It'll go
so,
down, yeah.
So both of these lines will go this direction.
Mm-hmm.
So I want this line right here to be one at the extreme edge of the window over here,
Gotcha.
because it's always going to be moving the other way. So which line is that? Do you see on the screen?
We need to move it further up.
Okay.
Yeah.
So we want this line. So I always pull my finger down, so it's going to be going this direction.
I actually can't see anything when you.
You might need to do it on the other side.
Oh yeah.
Okay.
So it's going to be going this direction.
Yeah.
Does
So
that
we
make
need to
sense?
move the.
So just get
So we
this,
need to put this,
this line
so it's
all
going
the
over
way
here.
against
Yeah.
one edge.
We have clearance with the camera, right?
Yeah, you plenty good.
So we're putting the dip all the way to the right extreme. And that looks good.
Okay,
Okay.
so now that dip can move this direction,
Yep.
and this one is in the middle,
Yep.
right? And it can move this direction.
Yes.
Great. Okay, so that's how you know the camera's in the right spot.
Okay.
So now we can grab those little blue lines and bracket the two dips, right?
If you have them in the right mode, which we're going to set up next.
Okay.
So go to the mark detection, and the mark color, right now we're looking for dark marks. On yours, we'll probably also be looking for dark marks, but we'll see. So go ahead and click on there, click dark. Basically change it to whichever one it finds easier.
And dark is like the Sharpie color? Is that what the
So
mark is? Or
it's really looking for reflection back. And some Sharpie, some
Okay.
like let's say you had a black pen but it was super glossy.
Mhm.
That would reflect more. It still would be light, but the color is actually dark to your eyes.
Okay.
So it's looking at
Yeah.
it's like oh I'm getting a bunch of stuff back here, but all of a sudden right here there's like nothing reflecting.
So
so that
so-
shows how much is being reflected.
yeah.
Okay.
So if you don't want to remember that, just have it choose the one that finds it easier.
Okay.
And then the mark search mode, we're gonna do manual. Auto detect says just go look for those gaps. But in manual, we're gonna slide those guys around it. You can't go with it in there. So we're gonna slide those and tell it where the marks are.
So this is a process, part of the process we have to repeat every time.
Yep.
Yep.
Very simple. Okay, and then go back to mark detection. And the last one was if it loses the mark, what do you want me to do? And you can either be auto reset or you can search where it last found them. And honestly, it doesn't really matter. I usually just put search last. But,
Okay.
okay. Now, we want that bulk material, that bulk gray and blue thing, to fill the window, but not go out of the window.
Okay.
Because we want to give it the most value that it can. So the way to do that is either you turn the light up. So as I turn, it's already up all the way.
But
So-
if you were to turn the light down,
So I can't make it go up any higher, but you can see what happens when I make it darker.
so it just
Okay.
made it darker and it went down.
So I'm going to leave the light all the way up, and then we're going to go into the sensor settings, I think.
Oh, I remember this.
And then you're going to change those bars from, you got high sensitivity and low noise, or long exposure and high speed. So if you go ahead and almost max out the long exposure, because we're going to be going slow, so we don't care about being high speed, so we can do long exposures. So see how that's got plenty to get it off the screen. And if you wanted to optimize, you could get the least amount of noise, and then give it more long exposure. You can fiddle with those if you want, but
Okay.
basically you should have it so that you're just below touching the top.
Okay.
Is that all good?
Yep, it's great. Okay, so we've done mark detection, sensor settings, and the last one is output settings. Very top. So this one is to tell the DAC system what information we're sending from the camera. So the first thing we need to choose is what we're sending out, and we're going to go ahead and click that. We're going to send out % strain. And I guess we can send out whatever you want, but that's what most of the other materials people had us do in the past. And we're going to choose what the output full scale is. Do you know how much strain your samples may take before they break?
No
Honestly, I
idea.
have no idea.
This
Okay.
is the first time they've been tested.
So 100% strain means that this test section would be doubled when you're done.
Aluminum tends to snap more than stretch.
Depends on type
what I
of
understand.
aluminum it is.
Okay.
But yes, you're correct.
I would be surprised.
I would say like 5 or 10%.
That's probably true. So if we choose, let's say we choose 25% and it goes to 30%, you'll lose the data from 25 to 30.
So I feel like 50 would probably be safe.
15 or 50?
50,
50.
25,
Okay,
50.
so let's
50.
choose.
I don't know, but
We can do that on the first one, and then we can back it down if we want. So the risk of choosing too big of a number is that you lose resolution.
Gotcha.
So
I feel like 25 will probably be okay.
25 probably will be enough, but
Yeah.
it's up to you guys.
yeah. Well, I mean, we've got 5 more after
That's
this
true.
too.
Okay.
Yeah.
And for now, actually, don't hit accept and close. Open the. We need to see the window. Yes, that window. Multi-purpose elite window. Okay. So this is the signal that it's getting from the camera right now. 0%. We need to make sure that this software and the camera software are scaled the same. So one way to check that is go back to this camera software. We're going to give it an output. We're going to set the output at 10 volts. So click on that run. It says run default. That was
Oh, sorry.
run default at the very top.
Oh, yeah, sorry.
Okay, so your options of what to send out from the camera are run, which is just read the current value.
Mm-hmm.
0, which means I'm going to simulate a 0 output from the camera. Or a 10 volt, which is I'm going to simulate the maximum from the camera, and negative 10 volts is I'm going to simulate the negative minimum. So we're going to send out maximum right now, which is 10 volts. Okay, and if this software is calibrated the same as the camera software, these two numbers will match. Which they do. But let's say you had chosen 50. You just happened to guess right. Okay. So if he had chosen 50 and then he told it to output that it's max and it showed 25, you'd be like, oh, they're off by a factor of 2.
We go back down to 25.
So
Okay.
we're going to leave it at 25. And for your information, Marcus, I'm going to show you how to change it.
So now do I want to change this back to run?
Yeah. And
Okay.
it would actually prompt you to do that anyway when you hit accept and close.
Okay. Anything else in here?
That's it.
Okay. All right.
Okay, and usually I like to have, I like to have strain be one of those so I can see what it's actually measuring. And then I usually set this one to length because that will tell you what your mark length is.
Okay.
And if I were you, I would write that number down or take a picture of it or record it somehow because that is your original length. So strain is defined as change in length over original length.
You just add.
And if you don't know that original length, then you can't back it out.
So you can't get the change.
Yep.
Yeah.
Okay.
So it will give you percent change, but it's still nice to know where you started.
Okay.
So,
And then is these have to have horizontal lines? Like, is there a way to make them like perfectly horizontal, or just
it doesn't matter if they're perfectly horizontal.
okay?
Because it's relative. It's just
Mostly,
Because it's just going to look at it's going to find that vertical line, and so let's say your lines look like this.
Yeah.
It's still going to take this point and this point. It's not going to start shifting unless your sample started shifting like this.
Yeah,
from
that'd
the
be
camera.
weird.
It would be better if they're straight, sure.
Okay,
But normally people just put the lines on with these guys,
great.
which should get them pretty straight.
Just use the 90s.
Yep. And again, it doesn't matter how far apart they are, as long as. So if your sample was really long, you couldn't make them huge because we only
Yeah.
have a window of 78 millimeters.
Yes.
But that'll be plenty of window for your samples.
yeah.
Yep.
Great.
And the thicker the line, like if you used a great big thick Sharpie, you'd have a really wide groove there. If you use a tiny fine Sharpie, it'll be super fine.
Okay.
I don't know that it matters a whole lot. It's just using an algorithm to find the center of it anyway.
Yep.
So
Okay.
pick your poison, I guess. The smaller line will be harder for it to see. So.
Yep.
Okay. Any questions so far?
I think we're good.
Okay. So the red lines show up when it's found the line. If that wasn't obvious. If it's having a struggle finding the lines, click on that button at the bottom that says begin next test. all that really means is lose the lines and refine them.
Ta-da.
And you may want to do that right before you start a test anyway, just to make sure it's zeroed and
Yeah.
as
It's,
approved and all that.
Yep.
Okay. Should we pull one?
Let's pull this guy. Yeah.
Let's pull.
okay.
And scooch it down. That looks good, yeah.
Can the camera still see all the lines?
Yep. Good. Okay.
Now,
So now
is there anything you might want to zero before you grip onto it?
The axial displacement.
Okay, so we did the force. The displacement doesn't matter anyway. The test is going to zero that at the beginning.
Oh, okay.
You could. It didn't hurt to do it, but your test will zero it anyway at the beginning. If we added that step.
Okay.
Yeah.
There's one other thing is that this would be the last time you have a chance to zero the camera percent strain.
Yep.
Because there's
Okay.
no force on it right now, but once you grip on it, there will be
Strain.
There will be
So-
some strain.
But it's real strain.
Yeah.
How do you zero that?
You hit the begin next test button down.
Oh.
Yep.
Begin next test. And it's zeros.
Oh, you know what we ought to do? I didn't show you this.
Okay.
So it wasn't exactly zeroed. The MTS software wasn't exactly zeroed. We probably should do that.
Okay.
Go to the output settings here. So we told it to send us a full scale signal, but tell it to send 0. Yep, that one and 0 reference. Okay. So this is off by 0.005%, which is not bad.
Yeah.
But this would be now, you right click there. So this is putting out 0. Now,
Zero
yep.
signal?
Now that's reading 0.
It's perfectly
So
zero.
those are perfectly centered. And then you go back to run mode. And so,
Okay.
and then
That's good to know.
if you wanted to, you could tell it to find them again so that it's fresh. Okay.
Sweet.
Now you're ready to go.
Okay. Now we're gonna use this guy. Remember to grip the top piece.
Since the sample's already somewhat buckled, we'll see. It probably won't put a lot. Got 100, almost 200
And
pounds.
it's increasing its pressure
Mm-hmm. So we'll wait for that
until
too.
it gets to 2,000.
Probably.
Still.
That's a very real foreigner.
It's real strain.
So, is it not because it's soft enough that as you squeeze it, both of them
pulling
are
it.
pushing up
Yeah.
because there's nowhere for the material to go when you squeeze it on the side.
Okay.
Okay.
So this, you don't need to this time, but this would be where you'd record. Actually, sorry, you should record your link before you before
Yeah.
adding your load. This would be too late now. but,
Yeah.
Okay.
Okay. Make sure that's. Oh. We have.
An error.
Ha.
Uh-huh.
Ha.
Okay, so ready to check your things. Look,
Not
the
locked.
top is not locked. I should have done that when we stopped moving it.
So now we'll try pressing this again.
Yep.
And
There
it's
we go.
green.
Let's let them run it.
Yep.
And
yeah,
then-
you guys run the test.
Where do we press the run button?
It is on the far left, that little icon up there at the top. There, right there. Run new test.
And then it's
Test.
gonna ask you for the stuff. Okay, so this
Don't
is where.
hit OK yet.
Yeah. So this is where we need to decide the rate and everything.
Okay.
So sample rate is how fast you're sampling the data. Like how fast are you recording your data?
Okay.
If we're gonna pull slow, 100 hertz is probably plenty fast.
Mm-hmm. What is a typical
We usually run 100 hertz.
ramp rate?
Oh, ramp rate?
Mhm.
So can you put the units in inches per second? Those are the ones I've memorized. Okay. So 1,000th of an inch per second is really slow.
Mm-hmm.
So when we do the 250 lab and we're doing those hard samples and soft
Yeah.
samples, so we do the water quenched ones slow,
Mhm.
1,000th per second. We do the air quenched ones about 5,000ths.
Okay.
So for hard steel,
You want to go slow.
1,000th is slow enough.
Mm-hmm.
5,000ths is kind of a medium speed.
So we could probably run at 10,000.
I don't know. I'd err on the slow side because you can always go back and
That's true.
you can't put extra data in after you've taken it, but you can always take it out.
Correct.
So I would go probably 2,000ths of an inch. Although this is just plain aluminum, so we may let's go 5. On your samples, I wouldn't go faster than 2 for the first one.
We
Okay,
have
then
2
you-
distance.
Yeah. Now we need to tell it how far to go, and we just want it to go till it breaks, right?
Yes.
And we don't know where that's going to be. So give it a number that's plenty far. So how would 2 inches break it for sure?
Yeah.
Probably. Yeah.
Okay. So let's do like 50 millimeters. And is it positive or negative?
Positive because it's pulling it down.
Correct.
Yep.
And then give it some kind of name like for us, training run or garbage aluminum or I don't know, whatever you want to call it.
Great, garbage run.
So are all those what you want them to be?
Yep.
Okay.
We got good hertz, very slow. It's a little farther than we think, and we named it.
And then just a warning, if you ever press enter with this window open, it will think you're pressing OK.
Okay.
So, great.
Okay.
So go ahead and press OK when you're ready. It won't start yet. So
So it's
now
gonna open your
it will
thing.
tell you to press the green run arrow. So clear that window. And then when you're ready,
It's just gonna go.
press that. So here's what you should do. Be ready to do as soon as you press this. So this red square is kind of your
Stop the test.
pseudo e-stop.
Okay.
If you hit that button, it will stop the test wherever it's at. You remember that flow diagram that it was following? It will stop wherever it's at, and it won't continue.
Okay.
If you click this button, that's the user info button that we told it to add. If you hit that one, it will jump out of that parallel loop and go down and save your data
Okay.
and end the test normally. So this is how you would end the test normally early. If something bad is happening, please go ahead and hit that. We don't care whether it saves the data or not.
Okay.
So those are the difference between those two.
Okay.
So,
great.
but if we don't want anything up, we just press run test and let it go.
So there
Or-
are three ways to stop this test.
Okay.
After you hit run, if it goes our full 50 millimeters, it will stop there. If it detects that it's broken by going to a peak and dropping 90% from that, that will also kick it out. Or if you hit this button.
So when would we want to hit that instead of letting it break?
Because it will break well before 50 seconds, 50 millimeters.
Okay. So once,
once we
it's broke-
visually see
Once
it.
it's broken, you can stop it. But
Yeah.
it also has that break detect which will
do
do
it
it
anyways.
faster than you can.
So you'd really only
Yeah.
need this if it didn't detect the break
Yeah,
for
if
whatever
it doesn't
reason.
detect the break, then you can stop it manually with that.
Great.
Thanks, thanks Marcus, that's perfect. Okay,
Okay.
go ahead and start whenever you're ready.
We're gonna run it.
I usually hover my mouse over one of the stop buttons so that I'm ready to hit it if something goes wrong.
Okay, let's do it. I pressed it.
Okay, so now you
So you can see the data rolling in. It's pulling.
Now, I also, this is good to watch while it's pulling. Watch your
Strain.
strain. Make sure it's moving.
Strain is moving, so it
And look at the force on it already.
it's
You can see it's plateauing.
Oh yeah. It's trying to break.
And you can, if it's a long run, you can even open that, or I mean, pop that window up so you can watch your extensometer go. But it seems to be doing fine.
You should see this one. Neck.
Okay, let's.
There we go.
Okay,
And it.
And it saved it.
it saved it and it stopped. Go back and look at your data. Let's see if you
And
remember
the
how to do that.
data-
Not the actual data, but just the graph that it.
Okay.
How to do that.
We go to here,
Yep.
monitor.
Now, what if you had a whole bunch of samples you had pulled?
You would click on the one
You'd
that you
click on
wanted.
it and then go to monitor.
Yeah.
Okay, and you can also, let's say, how would you find the max from here just easily?
The max force.
Max force, let's say.
Max force. We've got our axial force right here.
Yep, and we also have it here.
We got it right
Just
here.
make a box around that with your little magnifying glass. And then do it again. So you can just pick it off the grass like that.
15.8.
So double click in here again, just to get rid of the zoom.
Okay.
So now make sure you're going all the way to the end because your max is going to be on this side.
Oh, yeah.
So draw your square. Well, now you missed it again.
Okay.
Yeah, just
Just
do the
grab
whole
that
thing.
whole
Just grab
top
the
line.
whole thing.
Yeah.
And your goal is just to make it narrow and long. There you go, just like that.
Oh, okay.
There you go.
So,
Our
this-
very max is like just above this.
yeah. And you can see that there's noise. How much noise is that?
A lot of noise.
Like, no, it's not that much.
Well,
Like around 25.
25 pounds or so. So
That's not
bad.
actually a
That's
lot,
not what
yeah.
it's supposed to be. So anyway, that's how you look at your data without actually having to go to Excel and pull it open.
Okay.
Great.
That's what
so you got preliminaries.
So then, is there anything we need to do with,
So don't do it for him, Marcus.
All right.
or I guess with the,
How do you get yourself?
oh wait, because this has the displacement, so we can figure out the strain from that. So
We-
would this not do anything if we didn't have the camera?
Correct.
Okay, so that's only there because of the camera.
Yep. And
Cool.
if this signal isn't looking good, your sample's slipping or your camera lost the marks or something, then you might as well end the test.
Okay.
Okay.
So
So what I think what we would want to do is we want to,
shock ya.
yeah, shock me. I think we would probably want to lower this, and then get the clamps unclamped.
So you just hold it while you do the unclamping, so it doesn't fall in.
So I'm
Or
gonna
you can just
undo-
let it fall. So it's fine too.
Okay.
You could just take them out
These
right
have
now,
the same
actually.
symbols on them. You can.
So, now that you've got this, if this was just sample you were doing over and over again, I wouldn't move this because you
Top one.
you
yeah.
now have the spacing how you want it. Everything's set
Okay.
up. You don't necessarily need to move this.
Best
Then
to
you just
just
have to
undo
readjust
this.
it again. Yep. Yeah. Just unclamp and pull them out.
And then,
That top one. Just
And again, with your samples, since they're so close, with these things moving together, don't stick your hand in there.
Yeah,
don't smush your hand.
that's
All
bad.
Yeah.
Okay.
Sharky.
Well, cool. Good job,
We
guys.
did
Look,
it.
you
Yeah.
just
Fucking
did a dog bone. Nice.
And then from that,
You
we
can
just
frame that, put on your
log
wall.
out,
Sweet.
or I guess we want to save it.
Yeah, we'll try to close it down. So,
Okay.
is that where we're stopping today?
Yeah.
Okay. And feel free, let us know if you want us to be here while
we
you're
do
doing your
it.
first samples. We're happy to
Is
do
it
that.
okay if we do it today?
Yeah, if you want to do it
Okay.
right now, you can.
Yeah, that would be
Yeah, I
great.
think we might do it.
Yeah.
It's set up. I mean.
Yeah, might as well.
Okay.
So now just
Okay.
So we'll watch while you guys set your own test up.
cool.
Okay.
I think, and so from here, how do we get the data?
I don't know. You guys remember?
Okay, let's see.
yeah.
So- Go.
I think you would probably go to file and just save.
No.
No.
we-
Okay.
It's cancel.
So we already saved the data. Remember where?
In here, so we have to.
So it's,
How did
it's
we
already.
get to it?
So just open Windows Explorer and go to where it saved it. So yeah, that guy.
It was in projects. I think you said tests.
No.
No.
You can see up here.
In your data.
It's in data.
Do you remember the tests or just that's the
Better. Garbage run.
Garbage run it, and then we open this. It'll open up in Excel, and you can see the data there.
We can just email that to ourselves.
Correct.
Yeah.
But we don't care about
Can you
this
stay here
because
for a sec? I'm gonna go.
because we don't care about this data.
Oh, okay.
So
Yeah.
I'll just
So then
say-
is the best way to do this, just get this and then use like Matplot or something to
get this
get the
straight.
graphs again? Okay.
You guys have taken
Calm methods.
Yeah.
Yeah.
So yeah, it's literally just that. It's just that.
Okay. Cool. Yeah.
And if you forgot how to do that, chat is really, really good at teaching you how to take a CSV and make a plot.
Or doing it for you.
Yep.
I think we should.
I think I
Yes.
should be able to. I think we should.
Okay.
Yeah.
And then
But no, it's just living on the computer, so you can just email it to yourself.
Dang, this is